Here's something a lot of people don't realize. You do not need a GPU server to run a real language model. With the right format and a little quantization, a 7 billion model runs comfortably on a laptop, even on CPU alone. The format that made that normal is GGUF. The engine that runs it is llama.cpp. Let's see why this combo quietly changed local AI. Start with why we need a special format at all. The standard Hugging Face, weights, safe tensors are built for training. Full precision tensors sharded across files, glued to Python and a framework. Great for fine-tuning, but heavy and awkward for the much simpler job of just running a model on your own machine. GGUF flips the priorities. It's built for inference, packing everything one file needs: the weights, the tokenizer, the metadata, even the chat template into a single self-contained file. And here's the kicker. A small C++ program can memory map that file and run it with no Python at all. That self-contained, CPU-friendly design is why it's the default for local tools like llama.cpp, ollama, and LM Studio. Keep the two halves straight because people blur them. GGUF is the file format, the thing on your disk. llama.cpp is the engine that runs it. And that engine is clever. A dependency-free runtime that memory maps the file, offloads as many layers to your GPU as fit, and runs the rest on CPU. Ollama is just a friendly wrapper around exactly this. Now the part that confuses everyone, quantization tiers, that cryptic soup of names like Q4_K_M. Let's decode it for good. The number is the approximate bits per weight. Q4, Q5, Q8, lower means smaller and faster, but more quality loss. Full precision uses 16 bits. These tiers go down to around 3. The K means the modern k-quant method, smarter than the old round 2 nearest. And the trailing letter S, M or L is the variant, small, medium or large. So Q4_K_M decodes to roughly 4 byte k-quant medium. And the M matters because the medium variant keeps the important tensors at higher precision. Which is exactly why Q4_K_M is the community default. Almost all the quality at roughly a quarter of the full precision size. Q8 is near lossless but big. Q2 is a last resort when memory is desperate. Now the question you'll always actually ask, will it fit? The sizing is just arithmetic. File size is roughly parameters times bits per weight divided by 8 plus a bit for context. Two things fall out, worth holding on to. First, a tier is purely bits per watt. Quantization never changes the parameter count. A 7B model is still 7B at every tier. Second, the practical magic, dropping one tier is usually exactly what gets a model onto a smaller machine, at a quality cost you decide is acceptable. So when is this the right tool versus the alternatives? Here's the clean split, and it matters. A hosted API is simplest when you can send data out and pay per token. vLLM is for serving many concurrent users on your own GPUs, where page detention and continuous batching shine under load. GGUF and llama.cpp are for something else entirely. Single user, local, often offline. A desktop app, an on-prem box with no GPU, privacy-sensitive data, or just tinkering on a laptop at night. Optimized for one stream on modest hardware, not a fleet of requests. So they're not competitors, they're different jobs. So that's the whole picture. GGUF, one self-contained inference file, llama.cpp, the dependency-free engine, quantization tiers with Q4_K_M, your sweet spot default. And the deeper point. Running a capable model used to mean renting a GPU in someone else's cloud. This stack, put it on your own machine, private, offline, and yours. That's not a small thing. That's the whole reason local AI exists.